In this video, I'm going to show you how you do all of the analysis of unreplicated factorial experiments in JMP. I'm not going to show you how you can do it in SAS because it's not really, as far as I know, it's not really straightforward to do all that stuff without doing some additional programming. So in JMP, it's much more straightforward, and JMP is really geared towards these types of experiments anyway. So I've already done the coding of these four factors in that drill advance example: load, flow rate, speed, and mud, so that the lowest level is labeled as a -1 and the highest level is labeled as a 1. And I've also made all of these things continuous variables by changing them and clicking on that and going to continuous. But before they were nominal. I don't think you would see too much differences if you made them nominal, but this is just the way that we'll be doing these experiments later on, so I'd like to just keep it like this. So as far as doing the analysis goes, it's really not all that different from doing an analysis of a usual factorial experiment. We just need to see some additional tools. So I'm going to go to Analyze, Fit Model. I will put my response advance rate into my Y column, and I'll select all of my dependent variables, or my factors, and I'm going to put all of my effects in the model. So go to macros and then full factorial. So I'm going to get all of my effects in this way. And so before, we changed this to minimal report, but I'm going to change this to effect screening option for the emphasis. And so this is going to automatically tell JMP that we're trying to do some sort of preliminary screening without any designed error term. And so it's going to give us some tools that we can use to do the analysis that we need. So I'll click Run, and in this window it tries to give us the information, the R² value. So the R² is 1 because we have no error term anymore. So this summary of fit really isn't all that informative in this analysis, so you might just want to minimize that. And these are our estimates that I showed you in the slides, and these are ordered from largest to smallest, which is a little bit helpful to try to figure out which ones are important. Now again, these estimates are a little bit different than the ones that I defined in the lecture. These are actually divided by 2 compared to what I said in the lecture. So you just need to multiply these things by 2 to make it match with what I had in the lecture set. And so it automatically by default gives you all these length calculations. And so where it has the length pseudo standard error estimate is right here, so that's 0.45469, and here it tells you what degrees of freedom it uses for error for doing these tests on the right hand side. So that's pretty much it in terms of getting this to do length calculations. If you want it to output the half normal plot, then you need to click on this red arrow, go down to Effect Screening, and so you actually have a couple different options here. I didn't go into the base plot or Pareto plot, but these are also useful tools for doing screening of unreplicated factorial experiments. But we're going to go to normal plot, and that'll come all the way down to the bottom here. So by default, it does a plot using a normal quantile plot, and the blue line still is going to be a slope corresponding to the length pseudo-standard error. But it's a little bit more helpful for us to look at the half normal plot. So just click on this option here and go to half normal plot, and there's the plot that we want to look at. So you might want to make it a little bit bigger, and what we're looking for are points that are off this line. So JMP is doing some things in the background to kind of help you find those effects that are off the line, and it puts the names associated with them. And so this is how you can kind of let JMP tell you what are off the line a little bit more objectively, but you're more than welcome to try to do a little bit more of your input this way. So once you've figured out which effects you want in your model using either this method or length method, you would just need to go back into the fit model and remove those terms that aren't important. But other than that, that's pretty much all you need to do. It's a little bit more straightforward given what we've already known with the fit model platform.